In this video, we're going to look at using the compound interest formula in order to find the annual percentage rate required to accomplish some task. So in this problem, it says, what annual percentage rate is required for $250 to double in 10 years compounded monthly? So here we have our compound interest formula, and as I've mentioned before, this formula, you may see different uses of variables depending on what book or instructor you have, but you might see an A here instead of an F. A for the amount in your account. I'm using F for future value. N I'm using as the total number of compoundings, which you find by the compoundings per year times the number of years. So sometimes people will use two variables there, but it all means the same thing. As long as you know what the variables mean in the formula, you can plug in the appropriate numbers and then use the magic of algebra to find your answer. All right, so let's go ahead and see what we've got here. We're trying to find the annual percentage rate, right? What annual percentage rate? So that means we're going to be solving for R. We don't know what this R value is. Well, that means we have to plug in numbers for F, P, C, and N. We have to know all those things. Let's see. What do we know? Well, we've got this 250. What is that? You know what that is? Got it? Hopefully you're saying that's my present value, $250. What's my future value? Well, I want my money to double. So if it's going to double, $250 doubled, that's going to be $500. That's going to be my future value. All right, let's plug some of this stuff in. So we got our future value. We want $500. We currently have $250. That 1 is our 100% of our money that we're going to keep. That's always going to stay a 1. We're trying to figure out the rate. Let's see, C. What is C? The compoundings per year. Well, it's compounded monthly. Compounded monthly. So C is 12. If it was quarterly, it'd be 4. If it was annually, it'd be 1. If it was semi-annually, it'd be 2. It's just the number of compoundings per year. And then T is the total number of compoundings that are going to happen over this whole investment, all right? So did I say T? N is the total number of compoundings that's going to happen over this entire investment. So remember, this is 10 years, and we're doing this monthly for 10 years. That's a lot of compoundings. So the total number of compoundings, we're going to do this 12 times a year for 10 years. It's going to be 120 times that we're going to get interest over the 10-year period. Those are the compoundings. All right, so there we go. There's our equation that we have to solve. Now we have to use our algebra skills. So take a look at this and think to yourself, what would you do first? You're trying to solve for R, so your ultimate goal here is to get R by itself on the right-hand side of the equation. What are you going to get rid of first? All right, hopefully you're saying, I'm going to get rid of the 250. Divide both sides by 250. If you thought, maybe I want to distribute this 250 in here, well, you can't do that because of the 120th power, because of the order of operations. You have to do this exponent first before you would multiply this 250. So it's illegal to distribute this 250 in here, okay? Just in case you were thinking about doing that. So 500 divided by 250 is 2. And then on the right-hand side, we have 1 plus R over 12 to the 120th. Now, before we go any further, I want to draw your attention to something, which is this 2 right here. See this 2? I really didn't have to tell you we were starting with $250. I could have said what annual percentage rate is required for any amount of money to double. If I'd have said any amount of money to double, we would have put P as our present value, and then our future value would be 2 times P. That would be doubling. And then we would divide both sides by P. If we divided both sides by P, then we'd end up with 2, right? If you were starting with $1 million and you wanted it to double, you'd have put $1 million in for the present value and $2 million in for the future value. Then you would have done 2 million divided by 1 million, and you would have got 2. All right, I just put that in there to kind of make it a little bit easier to start knowing that I was going to highlight this idea. If you see this doubling problem or tripling problem, they may not give you a number to start with. So you can either use the variable, or you can make up whatever amount of money you want for your present value and then just double it for your future value. All right, moving forward, what are we going to do next? We're still trying to get r by itself over here. So we have to get rid of the 1, the 12, and the 120. The next thing to get rid of is going to be the 120. I can't subtract 1 out of here because it's trapped inside this exponent thing. I can't multiply by 12, same thing. It's trapped inside. I got to get rid of this 120. All right, guys, how do you get rid of 120th power? Well, you're going to take the 120th root, or take it to the 1 over 120th. All right, how do I want to write this? Let's try it this way. I'm going to write it both ways for you. Okay, so one thing you can do is the 120th root. I know, that seems crazy. 120th root. And that's going to cancel or undo this 120th power. So I'm going to have the 120th root of 2 equals 1 plus r over 12. Now, some of your calculators may not be able to do the 120th root, and this is where it's helpful to know, let me erase this, I'm going to need a little more room, that taking the 120th root of something is the same as taking it to the 1 over 120th power. And you could have done that on both sides here. Instead of the 120th root, you could have taken both sides to the 1 over 120th power. So if I have a calculator like this one, I don't know if this one will do the 120th root. I know the TI-84 and 83 will. And I can show you how to do that. But so for this, I can go 2 to the, I got to use quantity, 1 over 120, close parenthesis, and there's the value of 2 to the 120th, 1 over 120th power. All right, so we'll get back to that in a second. Let's finish solving this. I'm just going to leave this as 2 to the 1 over 120th power because I really don't want to write, I could write 3 with a bar over it. I guess that's not too bad. But I just want to punch this all in at once. I don't want to round this off because I don't want any round off error. I just want to wait till the end and punch it all in at one time if I can, after I'm solved for r. All right, so what are we going to do next? Well, hopefully you're seeing the next thing to do would be to subtract 1. So that's going to give me 2 to the 1 over 120, take away 1, equals r over 12. And then I have to multiply both sides by 12. So I'm going to multiply this side by 12, and I have to multiply this whole side by 12. Those 12s will equal 1, and 1 times r is just r. So now I'm at the point where I can punch all this in. All right, let's see what we got here. So here we had 2 to the 1 over 120. Then I'm going to subtract 1 equals, and then I'm going to multiply by 12 equals. All right, this looks like kind of a weird answer, but remember what we were finding. We were finding the annual percentage rate. So if you think of this as a rate, and we need to think about where we're going to round it, this is a percentage. So we would move the decimal 2 places to the right, and we'd have like 6.95%. Let's say we were rounding to the nearest hundredth of a percent. Let's go ahead and write that here. Annual percentage rate to the nearest hundredth of a percent. Not to the nearest hundredth, but the hundredth of a percent. So if I move this decimal over 2 places, I get 6.9515. Let me write those out. 0.69515. All right, move the decimal 2 places to make it a percent. So now I've got 6.95, and then this 5 would be in the 100th of a% spot. So I want to cut it off right here. So I look at the 1, which is less than 5, so I'm not going to round it up. I'm just going to cut it off. If this 1 was 5 or bigger, you would round it up. But since it's not, it's going to be 6.95%. All right, so basically really close to 7%. And this is called the doubling rule. It takes 7% to double your money every 10 years. You need to earn 7% to double your money every 10 years. That's kind of a typical estimation rule for compounding. All right, I hope you found this video helpful for using the compound interest formula to find the annual percentage rate.